In this report, we choose Rolls-Royce as our target firm and attempt to provide a strategy to help it develop core market competitiveness in the future and under the concern about mega chains. This presentation will be conducted in 4 sections. Firstly, we will use short pages to provide an overview of Rolls-Royce and introduce the mega chains being discussed in the report. Then we will analyze how Rolls-Royce responds to the mega chains in business planning and review the weak points in the context, followed by the possible reactions that Rolls-Royce could be considered to address the issues. Finally, in the strategy section, we provide critical recommendations for Rolls-Royce to implement the changes. So let's start with the brief introduction about Rolls-Royce. Rolls-Royce is a multinational which is based in the UK. It was founded in 1884 by Harry Royce with the business in engineering and motor cars. Then Rolls-Royce developed its defense business from the 2 world wars. Nowadays, Rolls-Royce relies on its advanced turbines to become a firm providing energy power solutions in the civil and defense domain. The civil aero engine business is sitting in the leading position of its revenue structure, followed by defense and power systems. MTU as Rolls-Royce subsidiary covered a business about various power systems, power generation, power supply for marine and railways. The revenue affected by the aero engine business reduction was due to the COVID-19 has a dramatic drop at 2020, with the future remains challenging. After learning about Rolls-Royce business, let's move the scope on the mega chains. In this report, we are going to focus on 4 identified mega chains and show significant impact on the future of power industry, climate change, sustainability, globalization, and technology. In brief, the growing concern on climate change issues has forced the firms to adopt sustainable strategy in business operation in the future. This might be challenging for the multinational running distributed network globalized. Decarbonization is becoming the new change in technology innovation, including the technical path through electrification, sustainable fuel, renewable energy, and nuclear. Digitalization is underlying roles towards the sustainable future that provides effective management support for the new power solutions, like the scope showing on the slides.
In the Analyze section, we combine with framework tools like business model canvas and market mix to analyze Rolls-Royce's strategy plan and behavior under 4 major industry trends: climate change, sustainability, globalization, and technology. Then reviews the shortcomings and possible improvement in 4 areas: research and development, supply chain, technology, and business model. Those figures introduce the layout of Rolls-Royce research and development in the whole life cycle and the global distribution of Rolls-Royce University Technology Center and Research Center. Rolls-Royce is very active in technology research and development. To meet the challenge of climate change and cater to the zero carbon strategy, Rolls-Royce global R&D network now mainly focus on research and breakthroughs in decarbonization technologies. Rolls-Royce has established a unique global innovation network, including industry, academic, and research. According to the U.S. Technology Maturity Level System, Rolls-Royce has formed 3 parts of different levels: 1 to 3, 4 to 6, and 7 to 9. Among them, level 1 to 3 is a basic research group to the University Technology Center around the world, and the university team organize the relevant technology research project. Other 2 parts, advanced manufacturing research center focus on the commercialization of common technologies, especially Level 6 technology is a key project of Rolls-Royce R&D funds, also known as system-ready technology, which has a certain degree of maturity but is still far from commercialization, which is the core of breakthroughs. Moreover, the globalized R&D system poses a challenge to the interaction of different players. Rolls-Royce recognized the importance of a digital system for global R&D, and its R2 data lab is located in 5 countries and provides service and support for data interoperability at the R&D and production end. From the above, it can be seen that Rolls-Royce R&D system is actively utilizing the convenience of globalization and digitalization to improve its core technology research and development ability, and has given a lot of attention to the decarbonization technology in line with the trend development. However, in management, Rolls-Royce R&D system is a typical waterfall configuration. It spent 10 to 20 years due to the high difficulty of the decarbonization technology project and the complex technology network. Although the waterfall configuration is good for the schedule management of large projects, but in the future, the engineering technology will develop more quickly, and the market will change faster and faster. The disadvantage of inflexibility of the waterfall structure will be magnified. For managers, it is challenging. On the one hand, it is difficult to respond quickly to sudden changes during project implementation. On the other hand, projects need to reach the final stage before they can enter commercial practice, which will lessen the payback period, especially for Rolls-Royce, which has a high percentage of technology investment spending. A shorter payback cycle helps to circulate the capital flow. The A380 project is a typical case of market failure in the aviation industry. The development of the flagship model requires a 10 years project cycle. During those 10 years, the needs of the market have changed. Reduced passenger demands for hub-to-hub routes caused the A380 to be shut down just 16 years after delivery. For Rolls-Royce itself, its early composite blade technology failure led it adhered to the hollow titanium alloy blade technology route. Will did not reveal the changes at material technology upgrade. But GE grabbed the potential of composite blend, which considered as one of the factors of GE when the contract of Boeing 777. Thus, it can be seen that Rolls-Royce needs to improve its flexibility and commercial application efficiency in their R&D structure to ensure it can lead their position in decarbonization technology. Rolls-Royce's globalization strategy is not only focused on technical cooperation, but is also reflected in its globalized supply chain system. Rolls-Royce has more than 18,000 active suppliers in more than 10 countries and regions. The main areas are Europe, which is close to home, and Asia and North America, where there are close business interaction. The globalized supply chain system enables Rolls-Royce to gain the cost and technology advantage brought by industry cluster. In order to effectively manage the supply chain system, Rolls-Royce applied digital management systems such as Airbar Info and global supplier portal to improve coordination efficiency. Despite the benefit of the global supply chain for Rolls-Royce, climate change and sustainability trends have brought the issue of supply chain decarbonization to the fore. Rolls-Royce has centered the strategy on the both net zero for its own production and operation activities and production emergency control, and the supply chain has become the second largest source of carbon emergency for Rolls-Royce. There are objective factors in different of managing carbon emergency from the global supply chain. Local differences in emergency policies and industry foundation have led to uneven decarbonization of supplier in different regions. Also, Rolls-Royce is aware of issue of supply chain carbon emergency and has taken measures, including carbon emergency review during supplier selection and decarbonization of supply chain transportation. Carbon emergency from supplier production practice remain the core issue. The lack of supplier carbon regulation and discipline could lead to threats to supply chain stability in the near future due to structural carbon regulation or import or export carbon reviews. The most pressing issue now is to establish a continuous supply chain carbon monitoring and target management system to understand the supply chain carbon emergency and integrate supplier decarbonization into the integrated management structure.
As mentioned above, Rolls-Royce is committed to making its products net zero running by 2050. Electrification and clean fuel replacement are the two most central technology paths. In the area of clean fuels, one of the first to be commercially proven was biofuel. Due to the production process and waste transportation factors, it is temporarily not available in large scale and low-cost supply to meet the huge demands. In addition, biofuel combustion has still carbon emissions and is not a completely zero carbon solution. Hydrogen is considered to be a more promising sustainable fuel. Although it is still mainly produced by fossil gas at the current stage, it can be produced with zero carbon when the electrolysis technology is manual. More importantly, the burning of hydrogen is efficient and total zero carbon. Rolls-Royce should further consider the commercial possibilities of promoting hydrogen solutions. Hydrogen production from nuclear power plants is considered to be the most promising option at present. Stable zero-carbon hydrogen production can be achieved by electrolysis of high-temperature water vapor generating from nuclear power plants. Although this option has relative cost advantage, it is still expensive. The SOE for nuclear power plants is a new direction and has a broader market prospect. It can achieve efficient and low-cost hydrogen supply. The nuclear power plant's hydrogen generation solution also brings up new opportunities for the future of the Rolls-Royce SMR. Although SMR has constructions and operating cost advantages over conventional nuclear power plants, its cost performance is still low compared to other power solutions. Where interest in nuclear power remains high in developing countries, some developed countries have moved to reduce their reliance on nuclear power. Therefore, SMR projects need to offer more added value to potential customers in order to be convincing. The hydrogen production function will allow nuclear power plants to bring more economic benefits and achieve a zero carbon cycle for the future power and transportation sectors. Thus, the development of hydrogen production from nuclear power plants can bring more potential to Rolls-Royce business. The pace of electrification seems to be fast compared to the application of hydrogen. Electrified hybrids are seen as the near-term achievable decarbonization options. Small aircrafts are ripe for electrification. The importance of electrification is clear from Rolls-Royce's decarbonization strategy. Rolls-Royce has not only developed a digital management system for distributed power to support different forms of hybrid solutions, but also collaborate with several companies and institutions to develop electrified power systems for different use and size of aircrafts. Despite Rolls-Royce's rich technical reserve in turbine fan technology, the battery components, which is a key to hybrid power, is Rolls-Royce's weak link. Rolls-Royce plans to invest £18 million in energy storage technology development in the next 10 years. Although electrification can effectively reduce carbon emissions and has relatively measured applications in the automotive sectors, however, the carbon footprint of the battery components themselves is an area that currently lacks attention. Lithium batteries, which are the mainstream of the aviation industry, have very significant carbon emission data for their production emissions, especially for raw material acquisition and bipolar material production. In addition to optimizing production technology, battery recycling is also an effective means to reduce carbon emissions. There are two options for battery recycling: raw material recycling and later utilization. The raw material recycling process still leaves a carbon footprint. Decarbon-emissioned carrier batteries have at least 80% remains capacity and can be used for other energy storage needs. Efficient battery recycling can reduce product costs and thus improve market competitiveness. Thus, in the context of the foreseeable rapid development of electrification, Rolls-Royce should focus on development of low-carbon recycling technology for batteries and effective battery laddering to further establish its business advantage on the sustainable strategy. In addition to the efforts needed on the technical side, we also see the limitations of the Rolls-Royce existing business model and its negative impacts on sustainability. It is clear that currently all engine manufacturers are still focused on the traditional production and sales model and earn their main revenue through post-maintenance service. Airline and aircrafts are their core customers. However, the expensive selling price of aircraft makes a heavy asset attribute of the aviation industry significant. The asset-heavy structure makes the stock market has little incentive to change to new engines, and the incremental market is affected by the epidemic. Competition will remain fierce in the future. Overall, the asset-heavy structure combined with the impact of the epidemic makes customers cautious in their decision to purchase new products. On the other hand, the market demand is not released. The penetration of new technologies in aviation system is slow, and it takes a long time for products with carbon emission advantage to gradually replace the old ones. Therefore, trying to change the business model is one of the possible ways to build further competitiveness. With the development of Model S, the improvements of engine compatibility can provide the possibility for engine leasing business. On the engine leasing model, customers no longer need to purchase engines, thus reduce asset investment. Incremental market demands will be opened. In addition, the leasing model also completely changed the structure of the inventory market. Airlines and aircraft leasers only need to pay a higher leasing unit price to immediately change to energy-efficient engines, as long as their overall operating costs fall. Opening up the leasing model will enable Rolls-Royce to differentiate itself and relies on its user base to achieve barriers. It also fits with Rolls-Royce's sustainability strategy to build low-carbon products into commercial operation more quickly to improve the decarbonization efficiency of the aviation industry.
To deal with the shortage mentioned in the previous analysis, we provide the following strategy to help Rolls-Royce adopt the changes in the practice. Firstly, to improve the feasibility of technical innovation and shorten the investment cycle, Rolls-Royce could consider to introduce agile idea into R&D management as a supplementary strategy to traditional waterfall structure. Secondly, to help strengthen the market competitiveness of Rolls-Royce decarbonized products, more technical investment should be paid to the battery recycling and hydrogen product areas. Rolls-Royce should establish cooperation with leading firms on battery recycling to work on the net zero battery material recycling technology. Furthermore, Rolls-Royce could work with its IT partners to provide a more efficient battery stageable utilization management system to extend the life cycle of retired batteries. For example, retired batteries from plane could be used for storing renewable energy in microjet system. For the idea of hydrogen production in SMR, apart from the measured electrolysis solution, Rolls-Royce should work on the SOEC technology for the broader perspective on scale production of hydrogen in SMR. Actually, Doosan in Korea has already started a tap on similar roles. Thirdly, to strengthen the monitoring of supply chain carbon emission, Rolls-Royce should cooperate with world-leading test agencies and IT partners to create a digital carbon emission management network. For example, the SGS Group has already published its first distributed carbon emission system. More specifically, the establishment of digital carbon emission management network could introduce embedded blockchain technology to ensure the reliable and recoverable data transmission. The AI technology could adopt in the mass data analysis to help managers setting visionable goals to urge suppliers works on the decarbonization in their operation. Finally, to implementing the engine lease service, Rolls-Royce should pay efforts on the development of software and hardware. The major change of lease model comparing with the traditional sales after-sales service model is the further highlight of service quality. It requires a more effective response to the customer demands. In the software part, Rolls-Royce should work with IT partners to develop an integrated engine management system that allows Rolls-Royce to allocate engines combined with the customer operational chains to maximize engine utilization while maintaining service efficiency. The existing EHM service to single engines will be connected together for management. The software update will expect to apply more usage of AI and IoT technology to build effective capacity. While on the hardware part, Rolls-Royce should develop service centers that covers major airports worldwide and to provide engine replacement service for customers and handle the engine care task. This could be achieved by cooperating with local airport service teams and also the existing Rolls-Royce authorized partner.